Hey there, welcome back to my channel. My name is Veronica, known as Data Geek. If you're new here, welcome. I'm all about data analytics and I use Jupyter Notebook with Python to break down complex topics into simple step-by-step tutorials. And in today's video, I'm diving into exploratory data analysis, also known as EDA. It's one of the important steps to understanding your data before doing any kind of modeling or predictions. And yes, I'm using Jupyter Notebook through Anaconda. And as you can see on my screen here, I have Anaconda opened up. There are many other apps you can use, but for this tutorial, I'm going to use Jupyter Notebook. You just simply click on this launch to launch Jupyter Notebook. And if you're wondering how to get that set up, don't worry, I've linked a beginner-friendly step-by-step tutorial in the description below. Now let's jump right into the code. So grab a cup of coffee and let's start coding. Okay, so here I am in my Jupyter Notebook, and we're going to be doing exploratory data analysis, which is also known as EDA. We're going to be using Python, using Jupyter Notebook. This is a step-by-step for beginners. The notebook covers loading and understanding the dataset, identifying and visualizing missing values, univariate and bivariate analysis, correlation heat map, and key insights. So what is exploratory data analysis? So EDA is the process of investigating and visualizing data to better understand its structure, patterns, and key characteristics. Before building blocks or drawing conclusions, it helps you to spot missing values, you can spot outliers or errors, you can understand distribution and relationships, and generate insights and hypotheses. In short, EDA is like getting to know your data. It's the first and most important step in the data analysis or machine learning project. Once you get to know your data, you'll be able to understand it better and know how to handle it better. Okay, so I will go ahead and add some cells. So I just click on this plus button here to add more cells. And in step 1, I want to import required libraries. I'm going to put this as a note. And I want to import pandas as PD. So this is for data handling. Then I'm going to import NumPy as NP. This is for numerical operations. Then I will import Matplotlib for visualizations. Then I will import Seaborn as SNS. So this is for advanced visualizations. So I will go ahead and run this code by rather clicking this play button here, or you can do a Control Enter if you're using Windows. So I'm waiting to see a number here. Once I see a number, I know that that has run successfully. So in my next cell, I will go ahead and set up a visual style for plots. And to do that, I just put SNS dot set, open parentheses, style equals, double quotation, white grid, double quotation, close parenthesis, and I will run that. That ran successfully. So this white grid, it's one of Seaborn's built-in themes that adds a white background with grid lines to your plots. So that's what that is. Also, I want to do another import. So I want to import warnings, and warnings dot filter warnings, open parentheses, double quotation, and I want it to ignore, double quotation, close that with the parentheses, and I will run that code. So what this does is it tells Python to pretty much pass all warnings so they don't clutter your output. This is very helpful when using libraries like Pandas, Seaborn, or scikit-learn, throws versions or some type of warnings. So we just want like a nice clean output. Okay, so now I will go ahead and go to step number 2. I'm going to load the data set. So we're going to use Titanic dataset. This is commonly used for data analysis tutorials. You can also replace this with your own CSV file, but in this case we're going to go ahead and do step 2, and we're going to load the data set. And I want this to be a note, so I put the number sign in front, and then I will start my code below. So I'm going to call my data set data equals, and then pd.read underscore CSV. Then I'm going to open my parentheses. So I already have this URL copied, so I'm going to paste it in here, and then I'm going to close that with the close parentheses. So I will go ahead and link this URL in the description below if you want to go ahead and use this. I'm going to go ahead and run my code. That ran successfully. So now I am reading this URL to pull this to Titanic CSV file. So now in step 3, we're going to go ahead and do a basic overview of the data. Because we want to look at the data set. So I'm going to go ahead and put data.head. So this is what I named my data set. So if you used maybe data frame like DF or something like that, whatever you named your data set, you're going to call it here. Make sure that's the same name as here. In this case, I want to only see the head of my data, so it will only run maybe the first 5 rows. I'm going to go ahead and play that. And here is my data set. I see passenger ID, method. Here's the name of the passengers on the Titanic ship. I see the sex, which is male and female, and then age, ticket, fare. So fare is like how much they paid for their ticket, cabin, so on and so forth, right? So we have 891 rows and 12 columns. Also, another way to view just this part, I will go ahead and show you another way. You can just put data.shape if you just want to see how many rows and columns you have. So that's data.shape. If you want to see the data types, you would write data.dtypes and then run that. And now you can see all of your variable names, which is your column names, and their data types. So passenger ID is integers, survived integers, names is object, same thing for sex, age, float. So you can check those out. If you want to look at your summary statistics, you would just go data.describe and put an open and close parentheses and run that code. Now you'll see the statistics for your variable names like passenger, survived. You have your count, your mean, standard deviation, 25% quartile, 50%, 75%, and max. So if you just want your standard deviations, that's these here in the middle. So next, if you want to see your null values, you put data.isNull. And you put open and close parentheses, and now you want to check the sum of those null values. You put .sum, open and close parentheses, and then you go ahead and run your code. Now you will see all your null values, how many you have in each of your variable columns. So age has 177 null values. Cabin has 687 values, and your embarked has 2. So next, if you want to visualize those null values, I will go ahead and go to step 4. So it's going to be plt.figure, open parentheses, and then your fig size equals, open parentheses, 10, 6, and you close parentheses and close parentheses again. Now you're going to do an SNS dot, and it's going to be a heat map. Open parentheses, and then your data set name is null. Open and close parentheses, comma, CBAR equals false with a capital F only, comma, CMAP equals single quotation VIRIDIS single quotation and close parenthesis. Next is your PLT.title. We're going to title this double quotations missing data heat map. Double quotation, close that parentheses. And now we're going to print it or show plt.show. Open and close parentheses. I'm going to go ahead and run that. So now we're visualizing these missing data. So here we saw the sum, and now we're visualizing. This is a heat map, and it shows age, and it shows how many missing values there are, and also cabin. That's how to visualize your data. So now we're going to go ahead and use Univariate Analysis. So we're going to analyze single columns. So this is step 5. We're going to go ahead and do, so let's start with age and fair. So these are the two columns we're going to use. So as you can see, age and fair here. Age has some null values, so we're going to drop those null values in here also. So we're going to do a plt dot figure, open parentheses, and then fig size equals, open parentheses, we're going to do 12 comma 5, and then we're going to close those two parentheses. Next we're going to do sns dot histoplot, making sure I spelled that, HISTPLOT, open parentheses, and then your data set name. In this case we have data, and then your variable name, open bracket, single quotation, age, single quotation, close that bracket, comma, and we're going to drop NAs, open and close parentheses. So that's supposed to turn blue, so sorry, it's not a comma, it's a dot. So dot drop NAs, open and close parentheses, comma. So KDE equals true with the capital T, comma, bins equals 30, comma. Then your color equals, let's do sky blue, close parenthesis. Now we're going to do the title, plt.title, and we're going to call this, double quotation, age distribution, double quotation, close that with the parentheses. Then plt.xlabel, we're going to do an open parentheses, and we're doing the age for the X label, close parentheses. Now we're going to do plt.show, open and close parentheses. So I'll go ahead and run that. Now if you scroll down, so it looks like a right screwed data, so also called as positively screwed. So right screwed data is when most values are concentrated on the left lower numbers, and the tail stretches to the right. So see, this tail stretches to the right. So it means a few unusual large values are pulling the data out to the right side. Also, I want to go ahead and explain to you about the univariate analysis. What this is, it summarizes individual columns. It checks for screwness or normality. It also is used to detect outliers or missing values, and it also decides on cleaning, transforming, or encoding data. Okay, so let's do another one. So this one was going to be for fair. So we did age, like I had mentioned, and the next one's going to be for fair. So I'm just going to highlight this and do a Control-C to copy. And then here I'll click in this cell and do a Control-V to paste, because it's almost the same thing, but the only thing is now we're going to call this fair, F-A-R-E, for that variable. And then the title is going to be F-A-R-E, fair distribution. And again, for this variable, again, it's going to be fair instead of age. And for this color, where it says light blue, let's do a light green this time. So I'll go ahead and run that code. And now you can see that the fair distribution, a right screwed, so it's positive. Just by looking at these, you can see that the range here goes very high for at least, I would say 20, a little bit under 20, and then a little bit over 30. So from this range here is the ages. So then you can see how many there are. It's very high in this age range. And then down here, you can see there's like 500 people that paid very low fares, to drops down to a little bit below 200. So anything under 100 looks like a lot more than above the 100 range. Gives us a good outcome of age and fare are right screwed. So that means many passengers were young and paid low fares, as you can see through this. Next thing we're going to do is we're going to do a count plot for categorical columns, like for P class. So let's look at the class. I'm going to write a note here. And it starts with sns.count plot, open parentheses. Now we're going to do an x axis of our variable P class, comma, then our dataset name, data equals data, comma, and then the palette, and then palette, P-A-L-E-T-T-E, and we're going to equal that to SET2, close that, plt.title, and we're going to call this passenger class count, close that with the parentheses, and then we do an x-axis, or x label I should say, and y label, so plt dot x label, open parentheses, passenger class, so these are our titles, double quotation, close parenthesis, and then plt dot y label is going to be our count, double quotation, close parentheses. Now plt dot show, open and close parentheses, and run that code. So Matplotlib has no SGY label. So I spelled label wrong. It's a typo. So it's Y-L-A-B-E-L. Run that code. And there you go. So what is P class? So looking at the data, the P class stands for passenger class. So it tells you what ticket class a passenger purchased. So think of it like a travel class on a ship, or similar to airline tickets of like today. So P class can stand for like 1 for first class, like luxury, expensive, and then also the spaciousness of that class. And then 2 would be like second class, and it would be comfortable, mid-range. And then 3 would be third class, which is just the basic, the cheapest, and it's also crowded. So as you can see, the cheapest one is a lot higher than the first class and second class. Okay, so now going to this next step, we're going to compare survival rates. So we're going to use a group by. So using group by, open and close parentheses, to compare survival rates. And to do that, we just do the data set name, which is data, and then group by, open and close parentheses. But in this parentheses, we want to call in the P class. So it's going to be single quotation, capital P, and then lowercase C-L-A-S-S, single quotation. Then we open bracket, single quotation, and it's going to be fair, single quotation, close bracket. So those are your variable names, and we want to look at the mean. open and close parentheses. So I'm going to run this. So now class A has 84%, and class 2, if we round that up, it's going to be 21%. Also class 3, if you round that one up, it'll be 14%. So as you see this, first class does have the highest survival rate, and then third class has the lowest survival rate. So this is probably likely due to less access to like lifeboats or location of cabins and deployed evacuations. So that's good to know. Now step number 6. We're going to do the bivariate analysis. So we're going to compare two variables. So bivariate analysis is the process of analyzing the relationships between two variables at the same time. Bivariate analysis. And we're going to compare two variables. And it's going to be, actually write another note, survival rate by gender. So you want to look at that. And to do that, again, it's going to be kind of like this one here. So I'm going to just copy this one here. I'm going to highlight it. So click and drag my cursor, do a Control C to copy, come back down, and do a Control V to paste. But in this case, we're doing X. We're going to do capital S-E-X for sex, male or female. And then here, after the sex, we're going to go comma. We're going to do H-U-E equals, double quotation. We're going to do survived, S-U-R-V-I-V-E-D, single quotation, comma. And then date equals date, comma, and then the palette, P-A-L-E-T-T-E, and we're going to set to, instead of 2, we're going to do it to 1. Now the title of this is going to be different. Survival count by gender. And here it's going to be X label. We're going to change that to gender. And then your Y label is going to stay to count. Now after count, double quotation, close parentheses, you're going to click there and hit enter to go down, because you're going to do another line. So you're going to do PLT dot legend, L-E-G-E-N-D, open parentheses, labels, equals, open bracket, single quotation, not survive. S-U-R-V-I-V-E-D, survived, single quotation, comma. And then you want it to survive. So these are going to be your labels. So you want not survived and survived. Single quotation, close bracket, close parentheses. And then the next line, plt.show. You can go ahead and run that. So these are your labels that we labeled, not survived and survived. So not survived is red and survived is in blue. You have your male and female down here for gender. See, just by looking at this, you can see that there's not survived. A lot more males did not survive the Titanic ship compared to females. A lot more females survived. So it looks like women had a higher chance of survival rate than men. So now going to the next one, it's going to be age versus fair colored by survival. PLT.figure, open parentheses, fig size, equals, open parentheses. I'm going to do a 10, comma, space 6, double close parentheses. Now SNS dot scatterplot, open parentheses. Now we're going to do our X equals, and we're doing age variable, comma, and then your Y equals fair variable, and HUE, equals survived. Actually, I need a single quotation, SURVIVED, single quotation. So remember, these are your variable names. So you need to make sure they are spelled just like they are in your data set. So comma, and then data equals data, comma, PALETTE equals single quotation. We want this to be a cool, warm, single quotation, close parentheses. PLT dot title, open parentheses, double quotation, age versus fair by survival. That's the title of your graph. So that will be the title of your graph. And then next, PLT dot show. I will go ahead and run this code. So now you can see 0 is for not survived, 1 is survived. And again, looking at this scatter plot, there's your fare. That's how much they actually bought their fare to get on the ship, and here's their age. Between a little below 20 to 30 is a lot bigger of not survived, and also they paid less than $100, probably even $50. You can see a lot more orange on top, so the people between this age that actually paid for a ticket higher in fare survived versus the ones that paid lower fare that did not survive. What if you want the numbers, right? What if you want numbers? So to do that, you can do a summary, SUMMARY, equals data dot group by. So we'll use a group by. And we're going to do survived variable, single quotation, close that with the parentheses, open bracket, so 2 open brackets, single quotation, and your variable name, age. Single quotation, comma, single quotation, the other variable name, fare, and then close those 2 brackets, dot mean, MEAN. Open and close parentheses. Now we're going to go ahead and print open parentheses, and this is what we're going to print. So do a summary, SUMMARY, close parentheses, and I will go ahead and run that. I forgot to, I spelled that wrong, so it's group by, and run that code. So here we go. Now we have numbers, actual numbers. So if you don't want to see a visual, you want to see actual numbers for this, you just run this code here. It's a group by, and you're looking at the mean. So age and fare. So next we're going to do a heat map for correlation matrix. So one of the most useful visuals in exploratory data analysis. So it's going to be step number 7, correlation matrix. First thing is CORR underscore matrix. We're going to do equals, then your data set name, data dot CORR, open parentheses, numeric underscore only, equals true. Close that parentheses. Now we're going to do a PLT, which plot dot figure, open parentheses, fig size, equals, or sorry, open parentheses, then equals. Now equals, open parentheses, 10, comma, 6, close parentheses, and close it again. SNS dot heat map, open parentheses, CORR underscore matrix. Make sure this is the same as this spelling here. Okay, and then comma, ANNOT equals true, comma, C map equals, and we're going to do blues. So we want it to be a blue color. So double single quotation and close parentheses. PLT dot title. Of course, we need a title for this. So we're going to call this correlation matrix, double quotation, close parentheses, plt.show, open and close parentheses. So I will go ahead and run that. So here's your blue heat map. It ranges from -1 to +1. The positive ones is the perfect positive correlation. Both variables increase together. It also correlates positive with its own variable, so that's why it's so strong. That's what these show. So a -1 is perfect negative correlation. So one increases, the other decreases. And a 0 means no linear relationship. So why use a heat map for correlation? To quickly see how variables are related, to detect strong relationships that could be useful in modeling, also identifying like two variables that are too similar. We can go ahead and say that age and fare are right screwed. Many passengers were young and paid low fares. Also, women had a higher survival rate than men, and higher class passengers, or the P class, had higher chances of survival, which is the class 1. And age and fare have a moderate positive correlation. So you can see age and fare have that positive correlation. So that is the end of my tutorial. I really appreciate all of your support. If you want to buy me a coffee, I'll put that link in the description below. But as always, any support you give, whether it's a like, a subscribe, or a share, I really, really appreciate it. Thank you again for watching, and I will see you on the next video.